Hi guys, welcome to our channel of Sciences and Mathematics. Today's topic of discussion is going to be on finding the cross product of vectors. And this is going to assist us, of course, in handling some of the problems that you may encounter that pertains to the concept of a cross product. And of course, we have seen that there is a relationship between the concept of a determinant that we learned in matrix and this concept of cross vectors. So there are some of the concepts that we have already discussed in some of our videos, and this is going to complement on those particular concepts that we have discussed, and it's going to give us a basis for, of course, working out the determinant or maybe finding out the products of cross product of vectors. So in this case, we're going to just have a look at the general representation for the cross product for vectors, and then we are going to proceed and do a work of one or two problems which will assist us understand the concept. So it is the cross product, and this specifically is the cross product of vectors. So in this case, we've done some of the, of course, we have looked at some of the ways in which we can be able to find the scalar product, and the cross product is going to be represented in a different way. Of course, we looked at the concept of a unity vector that we talked in one of our videos, and we gave different representations in which we can be able to represent maybe the x, y, and z components of a vector in three-dimensional space. So we are going to assume that these are some of the concepts that we have already discussed and understood. And maybe I'm going to put a link of the video in the description box so that we can just check. Now, by definition, the cross product of a vector, we're just going to use an illustration, and that is going to assist us understand. Now, suppose we have two vectors. Of course, that is for u, which has components in the x, y, and z direction, which are represented by u1, u2, and u3. And there's another vector, v, which has got components in the x, y, and z direction represented as such. So therefore, these two vectors are representations of vectors in three-dimensional space. The cross product u, v of the two vectors can be represented or can be defined as. So therefore, we're going to have u, v, which is given as u2, v2, v3 minus u3, v2. This is for the I component, and then we are going to have u3, v1 minus u1, v3. This is the j, and then we are going to have u1, v2 minus u2, v1, and this is going to form the k components. So in this case, this is a general definition for the cross product of vectors, and in a way we're going to see that this basically represents what we call or the procedure that we have been using in finding the determinants of matrices that we had, of course, indicated in our discussion for introduction to matrices. So we're going just to use an illustration and try to show how we can be able to come up with this specific formula for representation of a cross product of vectors. So therefore, we're going to use the components that we have been given in order to illustrate how we can be able to define this general formula. So I'm going to have that one in form of a matrix. So therefore, it's going to be u cross v is equals I, j, k. So finding the magnitude for that. So for the u, I have u1, u2, u3 for the I, j, and k components, and then v1, v2, and v3 for the xy, or I, j, and k components of that vector. So this is going to give us, so we know that from finding the determinants The first one is a positive, negative, positive. I'm going to illustrate that. So in finding this one, we are going to do a cross multiplication for the ith component is found by assuming or ignoring the first that is the first column for that. So we're going to have a cross product for this remaining part. So we're going to have the I component represented as the magnitude of u2, u3, v2, v3. And then the next one is going to be a minus for the j component, and we're going to find it by ignoring the j column for this one, and therefore we are going to use the remaining components and try to find the product for that. So therefore it's going to be u1, just use this, so it's going to be u1, u3, v1, v3, and then lastly plus the last component is going to be the z. So we're going to find the z by just having, so ignore this second one, so I'm doing a multiplication for those. So this is going to be k, the magnitude of u1, u2, and then or the determinants of u1, u2, and then v1, v2. So in this case, if we try to just do a multiplication for this, this is going to give us u cross v is equals, so this is u2 v3 minus, this is for the u2 v3 minus u3 v2. This is for the I component of that vector, I component. So if we go to the j, so it is minus j into u1 v3 minus u3 v1. Okay, this is for the j. I've just put it into practice specifically for the case of to cater for this negative sign, so it's just correct. So we go to the last one, it's going to be a positive, so therefore it's going to be k u1 v2 minus u2 v1. So these negative signs, we're going to represent this vector in form of ij and k. So therefore I just put this one, the bracket for convenience. So therefore this is going to give us a general representation as u2 v3 minus u3 v2, and then for this one, this first part of it is going to be a negative component, while the second one, since it's a negative, is going to be a positive. So therefore this is the first part of the second, the j component that is going to start first. So therefore we will have u3 v1 minus u1 v3. So that was the change that was to occur. Then we put a comma. The last one is going to be represented just the way it is. So for it to give us a general, because of this, for it to give us a general representation of the formula that we are given for finding the cross product of our vectors. So we're going to do this one using an example, just for practical demonstration purposes, and try to see whether it's going to assist us understand the concept. So I'll just do away with this. Now if we are asked to find, let me just use this space. So find u cross v, where u is equals 1, 2, negative 2, v is equals 301. So those are the specific quantities or the respective quantities for those two particular vectors. Now the solution for this is going to be u cross v, which is going to be represented as 1, 2, negative 2, 3, 0, 1. So we're going to use the same approach that we have used in finding for the I, j, and k by ignoring the first column. So the first component is going to be given by ignoring that, whereby this is 2 times 1, 2. So this is the I component that we're trying to find. So this is 2 minus 0. So this is 2. The second one is a minus, so we are going to ignore this second column and try to find the determinant for the remaining part, which is 1. So this is going to be 1 minus, so all of this is going to be negative, so it is 1 minus 6. And this is going to be for j. So this is going to give us, of course, we just continue and try to add. We're going to simplify the second part of it. So this, the last one, we're going to ignore this. So for the k, we're going to ignore this and find out that for k, this is going to be 1 minus 6. Okay, just a minute. This component that we had, of course, try to figure out. Just a minute. No, that is going to solve our contradiction now for this. Now for the j component, we're going to use this, ignore this and use this too. So this 1 minus, this is not 1, huh? Basically a number times 0 is 0, so this is 0 minus 6. So that's where our confusion is coming from. So this is a 2i, and the second one is going to be, this is plus 7, so negative 7j, and this is minus 6. Okay, so that is basically going to form our cross product for that specific vectors using that general formula that we had used in order to describe the cross product of vectors. And in this case, we have just solved this one using the concept of finding the determinant. So in this case, these two factors are going to have an interplay, and some of them are going to assist us in trying to find what we call the norm of vectors, and basically some of the theorem that we're going to encounter later in our discussions, or maybe identities like the Lagrange identities, which of course are going to stem from maybe the product of the cross and dot product of some of the vectors, and they're going to assist us in trying to find application for finding areas like the areas of a trapezium. But that is going to be a discussion for another day. So for that case, that is how we can be able to do a calculation in finding the cross product of vectors. And I hope this is going to complement on other areas that we have already discussed concerning vectors. So for that case, that is it for today. Thank you. Bye. God bless.